now am I messed up? Oh, there we go. Okay, so today's goal, the first goal is basically understand system memory. We talked about memory, in fact, we talked about memory obviously this whole time because in order to understand motherboards, we talked about motherboard bus speeds, and in chapter 1 we obviously talked about how the system clock synchronizes up with the system RAM. And when we did our motherboard presentation, I talked to you about how if you can't find a motherboard bus speed, you can just use the RAM speed because those two things synchronize up, and it wouldn't be able to use a speed of RAM that it couldn't synchronize with. So, and how we use, in general, the fastest non-overclock speed, because that is the native speed of the motherboard. But today we're going to talk more about the specifications of RAM. First of all, is RAM volatile or is it static?
Volatile.
Volatile, right? It gets refreshed all the time. And unlike your hard drive where things are stored permanently, they're very, very temporary. And it's where, is it primary or secondary to the CPU? Primary. It's the primary spot where the CPU holds all of its information. We're talking back from chapter 1 now. But the system RAM is where the CPU holds everything while it's doing all of its computations. Okay, it's what it thinks of as storage. As far as the hard drive and all those other permanent ones, the motherboard moves that information there when it needs to, but the CPU only talks to RAM. So we need to understand the different kind of RAMs that are out there. Okay, so there are basically two different kinds of RAM. Okay, there's static RAM and there's dynamic RAM. Static RAM is RAM that can be written to and stays where it's at without having to be refreshed. There's only one kind of static RAM on your computer. Okay, and that's your CPU cache. Static RAM is much more expensive. It's also much faster than dynamic RAM. And so static RAM is what's your CPU cache. You didn't have to keep rewriting it. Put stuff in cache and it stays in cache until it needs it, until it rewrites it. Dynamic RAM is much less expensive, not as fast, has to be continually refreshed every few milliseconds. In other words, it's being refreshed thousands of times a second. Okay? It has a memory controller that's in charge of it, and it's stored in memory modules that we put in our computer. So static RAM stays where it's at. Dynamic RAM has to be continually rewritten. Okay, so where we have static RAM, we have static RAM in our memory cache. It's faster but more expensive. I already said these things, and it's housed on the CPU itself. Our DRAM, or our main memory RAM, our dynamic RAM, has to be constantly refreshed. It's slower, and it's housed on our memory modules. We already know this stuff from last chapter, but it's part of the thing when we're talking about RAM. The difference between L1, L2, and L3 cache. We never talked before about the fact that it was in fact static RAM, but now you know. Okay? So in the memory chapter, this is kind of how things get expanded as we go. In the memory chapter, if I said L2 cache is dynamic or static, Ian, you'd say it was static RAM, right? You can expect that on the test. Because you need to know which one is which, and you already really know what L1, L2, and L3 cache is. You just didn't know it was static RAM because we weren't talking about RAM specifically at that time. But the new thing we're talking about now is dynamic RAM. And so the secondary goal is to understand the different types of memory that are out there and the different kinds of memory that we can get on our motherboard. We talked about motherboards. We talked about the form factor of the RAM slot itself. That form factor determines what kind of RAM can physically fit in our motherboard, but we're going to talk a little bit more about the evolution of RAM today and what kind of RAMs, what the kind of the differences are in RAM. Okay. So when we first started with RAM, and I gave these out the other day, we had these SIMs. And then we moved on. What we now have, and that's this kind of evolution of where we are, and this is the newest picture on here. That's a DDR chip. But as we evolved from SIMs into dynamic inline memory modules, and then those got faster, and those faster ones are evolved into what we have today. And we're going to kind of talk about some of the specifications of it. SD-RAM stood for, okay, it's SD. Okay, so what's the D for? Dynamic, okay? So the S stood for, or stands for, synchronized. What's it synchronized with?
The CPU for the motherboard.
Motherboard, okay? So current RAM is synchronized dynamic random access memory, okay? And when we came out with that, and the first one was this one right here, okay? We had SD-RAM, and everything we still have is SD-RAM. Everything's still SD-RAM once it came out. With the original SD-RAM, that was the original SD-RAM, and it had 2 notches in it. We don't have any of it anymore at our school, okay? And then to differentiate the form factor, they went to a 1 notch when we started with DDR SD-RAM. Okay, it's still SD-RAM. It's DDR SD-RAM, which is what that one is right there. And we went from 2 notches on it to 1 notch to physically differentiate the form factor of it. And the DDR part, does anybody know what that stands for? Okay, so the DDR, when we say it's DDR SD-RAM, it stands for, off the screen, double data rate. Okay, so as it evolved, the first one was called DDR RAM because it was double the speed of this one. Now, does DDR really mean that anymore? Of course not. It's way, 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 way faster. We're going to go through some of the speeds today. But the initial one was double the speed of SD-RAM. So we went from SD-RAM to double data rate SD-RAM. So at one point in time, for 1 year, DDR actually meant what DDR stood for. After that, it really kind of didn't. Okay? For a whole year. So we went from SD-RAM, which stands for Isaac.
Synchronized dynamic random access memory.
Okay, we went from SD-RAM to DDR SD-RAM. The DDR, Cody, stands for?
What?
DDR stands for?
Double data.
Double data rate, okay? And then, to differentiate, it just became the second generation of DDR, or DDR2, and then it became the third generation of DDR, or DDR3, and right now we're on the 4th generation of DDR, or DDR4. It doesn't mean 2 times faster than that, and 3 times faster than that, it's just generations.
That's what they
Okay?
should have done.
What?
They should have done that.
Should have done what?
That one's faster than that. That one's that much faster.
Well, it is faster, but they took over where the other one left off. Usually DDR2, the slowest speed of DDR2, matched the fastest speed of DDR. But they all were physically different, okay? They all had new form factors. So this one had that double notch dealio, like drawing is terrible. This one had a single notch. This one, the notch just moved a little bit, so you couldn't plug it in. And they just kept moving the notch over a little bit. So you couldn't physically fit it. The form factor was different, but the width was the same. The number of little silver pins on it were the same. They moved that little notch so you couldn't physically fit one in because it wouldn't work anyway.
When are they coming out with DDR5?
DDR4 is new, so it will be a while. DDR4 really just came out last year.
30
Or
years.
maybe the year before.
They just need a new one every year.
No. This is DDR3 or DDR was basically 2001. Okay. Yes. Yeah. Yes. Hoodie, you're gonna have to go to another one. I'm in the middle of class. Okay, thanks. Can people not hear me teaching when they just pick up the phone and do that?
I don't know. That one made me laugh though, because She was waiting, and all of a sudden she just started going, hello, 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 hello.
Okay, so no, this wasn't an every year thing. In fact, I don't have a year chart, although you could probably look one up. It's like every 5 years, really,
I'm gonna say
4
like
years.
every, like 4 or so.
We evolved into a new one. So I don't know that we can get past where DDR3 is right now, or DDR4 is right now, because really most DDR4, when we look at speeds, are actually way slower than the top DDR4. Everything else is an overclock because the motherboards really natively can't handle some of the fastest speeds of DDR4, which is why there's so many overclock speeds.
Let's make it better.
Persevere.
So right now, that's what. So these are generations. So if I said what generation is DDR3, you'd say
3.
third generation. Yeah, not very hard thing. Okay. And then they also have other nomenclature. It'll say PC2 in a number, or PC3 in a number, or PC4 in a number. And that number corresponds to its speed, but the 4 still corresponds to the generation of RAM that you're looking at. And we'll look at some of this. Okay. So this is original SDRAM, and then we evolved to the single notch one, which was DDR SDRAM, and then the notch moved a little bit. We got DDR2, and then the notch moved a little bit more. Can I hold them up and tell? No, I can't. I have to hold them up next to each other, or I read the little sticker. If there's no sticker like this one has on it, this one is it says 2 GB DDR2 800 ECC. Okay, so it is how big? 2 gig. It's 2 gig stick. It's a generation DDR2. Its speed (800 what? What? Megahertz, right? Memory speed, just like CPUs, is in hertzes, but memory is usually denoted in megahertz, whereas CPUs are denoted? Am I saying that right? In gigahertz, okay? And then the last thing on here we're going to talk about in a minute is ECC. And ECC stands for error correcting code. And ECC, or error correcting code RAM, only works in servers. And we'll talk about that in a second, but since we've just read it. If ECC RAM is for servers, what would be for non-servers? Non-ECC. I gave you the answer to the question. See? So it would either not say it or it'd say non-ECC for a regular old workstation gaming system or whatever. And we'll talk about exactly what ECC is.
Wait. What if you do put it ECC?
It will not work.
Really?
Will not start. Will blue screen. This computer takes ECC RAM. If I put non-ECC RAM in it, it will physically fit. If it's still the same, if it was DDR2, it will physically fit in there, and either it will start in blue screen or it will not start at all. It'll go beep, 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 because it's not the right kind of RAM. And I'll show you why in a minute, okay? Because it's totally different. So anyways, the notch moves a little bit, but one notch means it's DDR. Other than that, you can't tell without reading a sticker. Yeah?
I had a quick question about something that I wanted to ask you, but I don't want to get made fun of for.
Is this related to memory?
Yes, it is.
Okay.
I think it is. You said that there was the easiest thing to fix during the final exam,
Yes.
and everyone's gonna look at the guy like he's stupid if he doesn't do it. I forgot what that was. I wanted you to remind me what it was.
RAM?
That's,
Fitting in RAM?
that's what I thought.
Yeah. Good.
Okay. It makes that beeping noise.
I'm making a beeping one.
All right.
We'll show you that. We'll swap RAM out this week. And you'll see what the beeping sound sounds like from bad or no RAM.
Brandon says I wasn't here for this, apparently. I didn't know that.
It was before you swapped in.
Oh, yeah, okay.
Could have been. Okay. This is an old chart. We used to have synchronous RAM, and now we have DDR RAM, but really now we have DDR4 RAM. So this is an old chart from the book. Error checking RAM is completely different than non-error checking RAM because of what it does. So every single, I have to draw a chart, but every byte has another bit on it, okay, that it uses, and it's called a parity bit, in order to check that the data stored in it is good, and that's how it error checks it, okay? So what does that mean, Mr. Poole? Okay, so think of it like this. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I can't even do 9. I really want to do 9, but I can't. So let's say this is regular RAM. This is a byte of RAM. 1 byte in a stick of RAM. Okay, and then we know that it has many, many, many bytes, right? If it's a 2 gigabyte stick, it has 2. What's a gig? 2 billion of these spots on that one stick. 2 billion bytes, okay, on a gigabyte, right?
Yeah.
So there's 2 billion of these. And each one of these stores a 0 or 1 when it's writing data. That's the only thing they store. Okay? So there's 2 billion spots of all zeros and ones. On a ECC stick, let's see if I can.
There's a square. You might need to go there.
There's an extra one. Okay? And on that extra one, it does error checking. And if it depends on whether it's an even bit or an odd bit, depends on kind of error checking it does, we'll call this an even bit. Okay? Add up the ones, Isaac. How many ones do I have? I have 3, which means this one, if it's an even check, automatically gets a 1 written into it. How many are there now? What?
What? There's 4.
4.
Oh, I thought,
Okay.
I thought you touched up all of them.
The only thing that's in that bit is a 0 or 1 that makes it match the parity. Okay? So what it does is it writes the data like it would normally do it, and then it goes, how many ones do I have? I have 3. I need to have an even number, so I'm going to put a 1 over here. And then when it reads the data and said, oh, there were 3, so there better be a 1 here if it was written right. Because if one of these bits accidentally gets written wrong, and all of a sudden this is a 1, it fails the parity check. Because it went and goes, okay, there's 4, this should be 0, and this module just failed its memory check when I'm trying to read it. And it does that every single time it reads and writes on all 2 billion of those spots. Do you think ECC is faster or slower?
Slower.
It's way slower. Okay? ECC RAM, ECC equals slower. Okay? And it's slower because every single time it writes, this has 24 gig of RAM in it. 24 billion spots that every single time it reads and writes, each single byte. Yeah, now it does it really fast. It's not like asking Ian to add them up and he comes up with 9 when there's only 8 spots. Okay?
Like
I'm just kidding you.
It's
Okay?
not
But
that
it happens really, really fast, but it's happened really, really fast. 24 billion times, and how often does it read and write on synchronous RAM? Thousands of times a second, right? Because it's synchronous, so it has to keep rewriting it. And so every time it goes to rewrite it, it has to recompute this and figure out the error bit, fill in the error bit. Every time it reads it, it has to read it and calculate the error bit. Then it reads the error bit to see if it wrote it right and if it read it right. So ECC, the whole purpose of it is so that if I'm running something critical, my whole bank, Chase Manhattan's running off this server, that it knows every single time it reads and writes that it wrote the right thing that it thought it wrote. And there's never an issue. Okay? But it's slower. So why doesn't ECC work in a non-ECC machine? Because it has a whole other set of memory in there that a non-ECC machine goes, I don't know what it is. Likewise, an ECC machine's looking for that one. When you stick non-ECC in it, it goes, I don't know what you are, okay? So you have to match this. This is critical. If you buy the wrong one. Do you think ECC is cheaper or more expensive? It's slower.
cheaper.
Oh my gosh, no. You're paying for you're paying for a ninth more memory every single time. No, I was trying to do to you, okay? So it's more expensive. It's not more expensive because it does any calculations on the RAM chip. That's not where the calculations are done. Those are done on the motherboard. Okay, the motherboard's doing all this error checking, but there's a 9th more RAM on every stick, right? So you're buying more RAM than you ever get to see. This whole other set of RAM slots, if you will, this whole set of bits, because there's another, on this 2 gig stick, there's another 2 billion bits that the regular one didn't have, so you got to pay for it. So it's going to be more expensive. Okay, so ECC RAM is slower, it's more expensive, and it only works on servers. Now, I'm saying that with a little bit of a caveat. There are motherboards that can take either. There are. Okay? We had some HPs, and these were really wackadoo. Okay? We've thrown them away. We had them probably 3 years ago. Big, huge HP workstation machines. They could take up to 16 gigabytes of EC3 RAM, but it could only take 4 gigabytes of non-ECC RAM. Don't know. Well, that's how the motherboard was programmed. So if you were using it as a server, it holds 16, but if you were just using it as Xeon's desktop, it can only hold 4. Don't know. And if you try to put 8 in it, it would blue screen, and we tried.
That's like a big jump, 16 forward.
Yeah, well, think about it, it's a server or it's a workstation. Which one? And I guess they did it, it's kind of weird, but. So there are motherboards that can do both, but they are an anomaly. That's the only time I've ever even touched one that could do both. I didn't know there were ones that could do both until we got that motherboard. Okay, so that's ECC, and it stands for error correcting code. Yeah.
My bad, I read that as EEC.
Yeah. Error correcting code. Okay. So that's what it is. We got a whole extra bit in there, and it either stores it as an odd or even. You don't care. It's the motherboard that's doing that math, but there's a whole extra bit on every byte to go and do that error correcting code calculation. Okay. So that's one of the things that's new about RAM. Also about RAM, we have write speeds that we never really knew about before. You knew one thing, and the one thing you knew about RAM was the megahertz of the RAM, right? We might have known that. I'd say we knew about that, and although we didn't know what it was, we knew about the generation. In other words, we knew if our motherboard took DDR4, and we knew what the speed was in megahertz when we were comparing, and I said, get the fastest of this, or whatever. And you said what kind of RAM your motherboard took. But there's some other kinds of writing that goes on that also means something to us, okay? So when we say a piece of RAM, I'm going to come back to this slide, I promise, okay? So when we said a piece of RAM goes at, let's say, 2100 megahertz, we know that it cycles how many times a second? 2100 million cycles per second. Okay, so it does 2100 million cycles per second, right? Well, what's that mean? Does that mean it writes at 2100? Wait, I didn't write that up. That's 21 million. 21. I missed some zeros, right?
So
Okay,
two-
there we go. 2.1 billion.
There you go.
I didn't write it down right. Okay, so it means it does 2.1 billion cycles per second. Does that mean it writes at 2.1 billion times per second? No, because that's how fast the information's going around, but it can't write it that fast. He goes, I got a piece! I got it! It's like if I ran around with the textbook as fast as I could, around the room, and Ian had to grab chapter 2 on the way by, right? Can he grab chapter 2 just on the way by? No, there's 20 pages in chapter 2, and you can only get one page every time I go by. So how many cycles does it take for you to get to chapter 2?
I don't know. It could take
There's 21 pages, and you can only grab one page every time I go by. How many cycles does it take?
one cycle.
Ah, no! Because it's double data rate, and you can read going and coming, and each page has 2 sides.
10.5.
11! You can't get half a cycle,
He's
half a
doing it.
page. Okay, and RAM is like that too, okay?
Yeah, but then you're gonna need an extra page.
Yeah, you're gonna have an extra page.
Okay, yeah, that's true.
He's just gonna
You
read it
didn't use
twice.
all your RAM. Okay, so RAM's like this. It can't get it all. It gets a little bit. And it gets a little bit more, and it gets a little bit more, and it takes so many cycles to read and write, and that number of cycles is the column access strobe latency or the row access strobe latency depending on what it's writing. What does that mean, Mr. Poole? Because that doesn't make any sense to me. When it writes RAM, it's writing columns information and rows of information. They're all zeros and ones as they go by, okay? And it's grabbing so many zeros and so many ones on the way by so it can fill up the columns or fill up the rows and get its data, okay? And so there is a latency or a number of times before it gets all the info. For instance, if I said the latency was 12, that means it goes around 12 times before it fills up the column of information. Same thing here. Usually these numbers are the same. Very infrequently are they different. But that's how many times it takes for the memory to, the information to go by before that stick of RAM has the information inside its little table. Okay? So the latency is how many trips around the motherboard. So if it's doing 2.1 billion cycles around the motherboard and it takes it 12 cycles to write, then we can do math. I'm not going to do that right here. How long it actually takes to write. So when we look at RAM, do we want this to be a higher or a lower number? Lower. Lower is better. It means it wrote faster. Okay? So if I take two sticks that have the same speed in megahertz and are the same generation, the only other way I can see which one is faster is to know to look at the CAS or the RAS, one of those numbers. And usually, you see this, something like that. CL, or CAS latency equals 12. You usually don't get on the thing both of those, because they're almost always the same. But that gives us one more way to compare. Just like with CPUs, really most people just look at the gigahertz on the CPU. They don't realize that that they should also be looking at the number of cores, the amount of cache. When it comes to memory, not only should we be looking at the megahertz and the generation, we should be looking at the cache latency. Because not all eggs are the same.
I feel like that's going to have a big part to do with our PowerPoint.
Well, I mean, it's going to be one of the things you're going to talk about in your PowerPoint. Because when you talk about your memory, you're going to talk about those things. Okay, my motherboard takes 4th generation DDR4. My fastest speed is 2100 non-overclocked. And I got this one from Kingston with a cache latency of really low. And why is it the best? Because it's the best cache latency you can have. And I'll show you a chart that shows the different cache latencies you can have for different speeds of RAM. Okay, so this is a new term for us, the cache latency. Okay, we learned ECC and non-ECC. Now we've learned cache latency is one of the things, and it's the speed that it, or how often, how many cycles it has to take in order to fill up that column of information.
Is 12 seconds of cast like horrid in the
No. I mean, think it's doing 2.1 billion cycles a second.
Okay.
The fact that it took 12 of those, okay, that's 1 over 2.1 billion. So it'd be then, I mean, okay, we'll do the math, Ian, since you're making me do the math. Okay, so that means it does 12 or 2.1 billion. This is how long it would take, right? If it takes 12 cycles,
Yeah.
and it does 2.1 billion cycles per second. If I do that division, I end up with how many seconds it takes to write, right? So now I don't think I'm doing this one in my head. So how long does it actually take to write to that RAM?
I'm going to guesstimate 500s.
So we do 12 divided by 2, 1, 0, 0, 0, 0. Is there 3 more O's?
No.
There's 100,000. There's 1,000. 100,000. No, there's 3 more O's.
No. Really? No. You sure about that? 5 seconds?
No, let's see. 2.1 billion to
It's to the -9.
1 0 0 0 0 0
Right.
0 0 0.
We're
Right?
just gonna say I was right.
5.7142 to the
Yeah,
-9.
it's really small.
So we're gonna say I was right.
So okay, I don't care. So my point is, it's still really friggin' fast.
Okay.
Okay, the fact that it took 12 cycles and it's doing 2.1 billion cycles per second, it's not like in the realm of things. It's, oh man, that cache latency sucks. It took 12 cycles. Okay, it's still really fast. And honestly, the faster it's going, the more cycles it takes because it's going by so fast and Ian can't get it all. He can only get half a page now because it's going by so fast. He's like, yeah, okay. So you'll see as we go up in DDR, we also went up in CL because it just couldn't write that fast to the actual piece of memory. Okay. So and I guess that's why when you ask, are we going to DDR5? At some point, you can't even get the information shoved into the stick of RAM. It's going by so fast on the motherboard. Which is why when you overclock, you have a chance of getting blue screens because you're basically forcing the motherboard to handle the information faster than it really was rated to do. And hopefully it works good. And that's why I don't like to overclock anything that matters. If you overclock your gaming computer, you're getting awesome frame rates and everything when you're playing whatever new game we're playing today. Who cares if a blue screen's and shut down? Yeah, you were just about ready to shoot Ian in the back of the head, and then my computer broke, you know. Okay, who cares? Well, Ian does. He's like, woohoo! Okay, but if it was a banking system, we wouldn't want to overclock and take a chance that that bit got by and I didn't get it written, and now my computer blue screens. Okay, so there's a physical limitation that we keep pushing up against, and I'm sure we're going to figure out a way to get past it, or that maybe they already have. But
Is there anything you can do for a blue screen?
yeah, restart your computer.
Yeah.
Is it?
Uh-huh.
Like
What
like,
if it blue screens because like it had like a super surge?
Then
you're screwed.
fried. That's why you get a surge.
I mean like
Surge
lightning
protector.
struck the outlet and super.
But if you have
Would the surge protector help that?
a
Well,
surge
yeah, that's what.
suppressor-
No. A real good surge protector.
Okay.
Like, man. Like
That's why you make
directly
sure
on
you
the
have a
outlet.
warranty.
I mean.
That's why we go back to the get one that has a warranty.
This is
So you get a whole new
advanced
computer.
Like the month after I started this class, at work I walked in and they were like, so lightning hit one of the metal rods outside and went and just straight up screwed the computer and it was blue screen. They were like, yeah. I was like, that sucks. I don't have to do for that.
Probably for something I don't know. So. Well, we're talking about how memory affects the speed of a computer. And really, that's what this slide is. Because how much memory is installed does not truly affect the speed of the memory. The memory is the speed of the memory. Okay? But how well the computer runs is going to be rated to the megahertz. And it says PC rating, but you can take that as generation. Because like I said, it'll say PC1, PC, or actually it'll just say PC, PC2, and now we're on PC3 and PC4. So the generation of the RAM will obviously affect it, and faster generations go with faster megahertz, and we don't really talk about it in nanoseconds anymore, but that's the calculation we just did. Okay, it used to give us that, but now the number is so small, you know, e to the -9th, that people are like, what's that mean? It's like, we can put that on there. We just talk about the megahertz and the PC rating. How much memory installed definitely affects our PC, because the more RAM that the CPU has to work with, the less often it has to save out anywhere else like our hard drive. Memory technology used, in other words, well, I hate to say that, because when we're talking about memory technology, memory technology, let's talk about, we'll talk about, there we go, all right. Most RAM in motherboards do dual channel some of them now do tri-channel, and some of them do quad-channel RAM. That's one. So that's an L. That's a new memory technology that's evolved, and what it really means is that on dual-channel RAM, for instance, these all have dual-channel RAM, and what that means is if you put in matching RAM, it can talk on more than one channel at a time. It'll be reading one while it's writing the other on the way by. So it gives it a faster way to access the memory. Okay? In order for dual channel or tri-channel or quad channel to work, all the spots have to match exactly. You can't put a 2 in one and a 4 in one and an 8 in another. They have to be the same kind of RAM, the same speed of RAM, and the same size of RAM. For instance, let's say this had 4 gig RAM in it, and I put in a 4 gig stick. I turn it on, and sometimes we see this memory would be better put in. Okay, I said that wrong. Okay, here, I'm going to draw a picture. When we looked at our motherboards, we frequently saw something like this, not necessarily purple, but we frequently saw on your motherboard 4 spots of RAM in 2 different colors. Okay? The reason they were in 2 different colors is because these go together and these go together. And if I had 2 sticks of 8 and I put one in here and one in here, I would negate its ability to do dual channel reading and writing. And usually the motherboard will give some kind of a BIOS error saying, put your RAM in differently, dummy. It's not what it said, but it said, your RAM could be better configured to maximize the use of dual channel architecture or something like that. And people go, oh, I don't know what that means. And you don't know what it means because it's really saying is you put your RAM in wrong, dummy. Okay? So those colors mean that if I want to use dual channel, I have to match them. So if I had a 2 and a 4, it doesn't matter. Can't use dual channel anyways. But if I had a 4 and a 4, I'd want it to be here and here, not here, so that it will use the dual channel architecture and it will read and write faster. So when we're talking about memory speeds, if we have the memory technology for dual or tri or quad channel, and your motherboard should say that, what kind it takes, then you have to put in the right kind of RAM for it to work. How much difference does it make? Not a ton, but if you've got 2 of the same, put it in so it's the fastest you.
So dual channel means that the 2 of them are linked.
Yes, and it will read and write in those together. And usually what it means is as it's going around, it'll read one while it's writing the other one, and write one while it's reading the other. So it does kind of a synchronized read and write. Otherwise, it goes around and says, okay, we're writing this trip. Okay, we're reading this trip. And it's supposed to be slower if you don't use it that way. CO rating we already talked about. That's the latency that it takes to write, and a lower number is better. And then we've got error correcting code or parity bits or non-error correcting codes or non-parity bits. Those all affect the speed of our memory. Okay? So we've got those things. I've got a little chart. I've got a little chart that kind of lets you see more memory can be faster, newer technology is faster. Another DDR4 is going to be faster than DDR3. We don't really look at the nanoseconds anymore, but you could calculate it if you wanted to. Faster megahertz is better. Newer generations is better. Non-ECC is better than ECC, and a lower CL or RL rating is better. So as you compare things, and on the test I'm going to give you ones that look very, very similar. They're both DDR4. They're both 21 megahertz. Which one's faster? Then you have to drill down in the specifications and find that CL rating. Or it might be that this one, okay, here's one. Okay. So I got 2100 megahertz DDR4 CL 12 2100 megahertz DDR4 CL 12. Which one's faster? They're the same numbers, Mr. Poole. How do I know? Oh, I do more reading.
I'll wait for you to give us more information. B is faster.
Okay, so you have to go and look it up, right? You have to go and look it up. If all these numbers are the same, then I have to keep looking to see what differentiates the two. And if this one's ECC, it's server, and it's definitely going to be slower. Okay? Questions so far? So your assignment for the rest of this period, you're going to read the Memory Day 1 article and take the first set of questions on the Memory Day 1 article. Is where we're stopping at right now. And then next class, we're going to talk about buying RAM, and we're going to take out and replace RAM, which you guys have already done, right? We tore apart the PCs all the way down to nothing and put them together. How hard is it to put in RAM? It's not that hard. Just got to make sure you got the right kind of RAM for the motherboard. I've helped people buy computers before. I'm going to take a little break here before we start reading. I've helped people buy computers before, and
They like buy and run RAM, they try to put it in.
they'll go and they'll go and say, oh, I'm gonna go Newegg, I'm gonna get the best RAM I can get, and it's RAM, and I want 16 gig of desktop memory, and I want, man, I really, well, of course I want new, and I want 8 gig per module, and see, you can see the cache latency there. See how there's one that only has 2. Most of them have 6. Some of them have 5. All the same thing so far, right?
2? That's like light math, right?
Yeah, but I bet you it's old. Let's see. I bet you it's DDR. No, it'll lie to us. Liar. There's none with cache latency of 2. Liar. It looks like, okay, there's some with 7 now. Let's see if. Okay, and that's PC2 or DDR3, and it's DDR3 1600. But what I was trying to get to is they'll go and they'll look and they'll get the fastest speed. That they won't check that speed's supported by their motherboard, because even if you get the right generation, you guys know from your own motherboard presentations had a list of speeds that it took.
Yeah.
That wasn't every speed that's made.
Yeah.
It's just a list of speeds. Okay, and in fact, I'm going to go ahead on my little thing here a little bit. Let's see. Okay, so here's DDR, the original DDR. Okay, it originally started as DDR2. It's going to sound weird. 200, which had a speed of 100 because it was double data rate. It's called DDR 200. Okay, it's twice as fast as what the actual clock speed was. So DDR, the original DDR went up to 400, and then the next one started off, DDR2 started off at 400 and went up to 1066. And then DDR3, well, this doesn't show the whole thing. Dang, no, this is the one that had relative versus the clock ratings. I didn't make donuts for donuts in my charts. This one is though. There's the DDR3. So DDR3 started out 800, went up to 2133, and then DDR4. Don't have the right chart here. That's started out 1600. It goes faster than 2400. That's not the right chart. But anyway, so you can see here's the timings over here for the CLs. They go on DDR4. They go from 12.5 to 15. Whereas when we were way back at the original DDR, they were back at 2s because it was slower. It could write in less cycles. Anyways, I'll let you go and do your reading and answer those questions right now. Okay, and I want those sheets done too.
Right now?
This class?
Well, how hard would it if you already got it graded? Okay, do the work, and then if you're done, do the sheet.